All right. Okay. Just posting the link now. Yeah. Cool. Okay. All right. That should be posted to Blue Sky. Yep. Cool. One. Oh. Yeah. One day I'll figure out how to get the link for this before I actually start, so that I can do this a bit more smoothly. One thing I have, I think I've gotten figured out is hotkeys to actually switch to scenes now. So hopefully we'll have fewer of these things with the chat getting stranded and such. Now, one thing unfortunately I haven't managed to get the chat up correctly, so let me just fix that. Not sure why this isn't working properly. I'm just trying to get the chat up in a way that I can see it alongside. Okay. Yeah. Chat. Yeah. Okay, now send this to the previous workspace. Okay. Now, this one. Okay, cool. That should be sorted out. So now let's just double check everything's together. Yep, cool. All right. So quick recap for where we were, for where we are, and what we're doing. Okay, and we're working in a So where we are now is we've stubbed out this pipeline class, and the key idea is that there's a master model class that is owned by the pipeline that runs all of the ML together. And this is different from the way that it works in spaCy at the moment, where all of the components own their own distinct ML models. And the way that we do it in spaCy at the moment means that we can't optimize all of the models together, which means that the pipeline ends up involved in the training, and we can't use generic tooling from the PyTorch ecosystem to do the optimization. And in general, we can't make full use of the library and the ecosystem and the advantages that we hope to gain from porting across to PyTorch. So yeah, the master model will be run once, and then the predictions are passed to the components. When you add a component, you register it with the master model as well as with the pipeline, so that you still define models with the components. I think that's important. You don't want to design one model that does a whole pipeline, because then you end up with the sort of factorial combination of models for whatever combination of pipeline components you want. It's important that they sort of plug together. That's sort of key functionality for an NLP pipeline. The next thing that is on the list is to look at serialization and deserialization. I think it's very tempting to delay looking at this, but that's generally unideal, because it's problems here can inform problems elsewhere, and there's no getting around the need to serialize and deserialize. It's absolutely essential. It's part of any workflow. So thinking it through and making sure that the design supports good serialization and deserialization practices and conveniences is important. All right, so let's look at this. Now, I'm going to have to ask Claude a few things about serialization and deserialization in the PyTorch ecosystem, because this is something that I haven't really done before. So let's look at this in the master model first. Okay, so let's see, here we are in our model scratch, and that's our abstract base class for the component model, and here we are for the full pipeline model. Okay, so let's ask this. Okay, so so hopefully this will have transitioned us to the browser view, and it has not. Okay, so that hotkey isn't working. Alright, whatever. I'll do this the way it was before. Okay, so wait, where's the transition button? Oh, wait, I am, okay, so yes, it's up. All right, cool. Wait, no it isn't, no it is not. Why is it not? There was a button here before that is not here now, which is really confusing me. Okay, so one second. There we are. Okay, cool. All right. Yeah. So now let's see. Is that actually big enough to look at? No. All right. Hopefully it is. All right. Save, load. Okay. Okay, so just as a quick context for this, it's important that we do the serialization so that we don't, so that it can't use pickle when it's deserialized, because if it requires pickle, or like if the deserialization goes through pickle, we get two problems. First of all, there's a security problem, potentially depending on the usage context, in that untrusted models can execute arbitrary code. So that we see that as unideal, and that's not how we've done the spaCy models in the past. Then the second problem is that you can have pickles that are tied to a specific Python version, which is just a hassle, or unideal. So and sometimes even platform can matter. So we want it to be much simpler than that and much more portable, and so we want to make sure that we're only serializing the weights using a format that can't execute code. So this is what we've got to work out, and then there'll be other potential data on the model that we can load back in that we can load up in a different way. So, okay. Alright, so this looks basically correct. So we go save state dict. So So this is another thing that's a bit annoying. I think it's important to support serialization, not just to paths, but also to bytes in general. This makes it much more flexible and avoids a situation where you need to pass the function some like dummy file that then you read from it. At the very least, the civilized thing to do if you need to do it to paths is to take a file object so that somebody can do it at bytes IO. Because otherwise, to use this, if you actually wanted the bytes, you would literally have to pass, create a temp file, pass it in, and then read the temp file, which is not what we want. So we would like this to serialize the bytes. Did the browser disappear here? I don't see it on the stream. Okay, so no, that's not it. Alright, yeah, that looks right. Okay. Yeah, cool. Alright. So okay. Alright, so PyTorch lets us pass in a buffer here rather than a path, which is all very well. So let's see. So we go import hello. bytes buffer. That's concerning. Is the typing out of date in this, or okay, so pickle module, is that it? Pickle module equals none, okay. So, yeah, alright, in theory this should save out to save our state dict and get, we should get bytes from this. So let's see. Bytes. Okay. So go. And then we need to know about these components. So how are we doing that? Maybe this actually isn't the best way to do it. Instead of having one top-level state dict, we should do it like this. So disabled, we would go under disabled. So, components. Okay, so yeah. Items, text. So we go. Gifts. Okay, and then we go self._disabled. Okay. Right, so now that we've got those, we can do our 2 bytes and from bytes quite easily. So we go to bytes, we go data, soft.to-bit, and then we return. Now from disk, self-path. There we go. That's data. Cool. All right. And add this import. So, all right. So what we're doing here to serialize is we're going to call these component from to and from disk, which means that we need to fix our typing here. We can't take arbitrary torch modules. We need these to be component models. Okay. Then here we're going to have bit. Alright, so now let's think this through. One thing we're not doing already here is calling super. So the question here is, when we serialize, do we want to change any of this state? I think the general principle should be that, if you take arguments as in the constructor that we can see as immutable, that we're not going to change, that we're not going to modify during over runtime, then it doesn't make sense to serialize those, because on the way back in, you should create the object the same way and then load the state. So what we should be serializing is transient state, like or mutable state, so that you reflect whatever you did to the class in the serialization. So the general thing here is we need to know what, so this, for this class, we need to have it, these parameters that it owns, it needs to serialize those, but okay, so now another question about PyTorch. So, yeah. Okay. So wait, it automatically gets them from your instance attributes? Oh, it's a little bit evil. Okay, all right. Well, that's how it's done. That's how it's done. So yeah, that's why you've got these wrappers like module list and module dict. Okay, cool. Okay, so this means that this encoder, if we store that, that's saved directly. Okay. All right. Okay, so let's say we're creating this tagger model. What are we doing here? So we need to know about the encoder. We need to know whether we're using short embeddings. Okay, and we're going to need various options. So let's see. We've got, I don't know, deal with so and yeah, then okay. Right, so we go and then okay. So oh, default is 0.5. That's weird. Okay. Yeah. So we're getting to some things here around the configuration and stuff, which, you know, spaCy has a fairly intricate solution to this sort of stuff. And I think it is actually better. Basically, what we do in spaCy is we have this separation between when you define the you know, the object, and then an initialization phase that needs to be called before you can actually do anything. And instead of initializing, you can also deserialize. So what this does is it prevents you from creating the objects twice, and it means that you've got sort of a phase in between the creation of the thing and when you actually, you know, initialize. And then you can also initialize with some data so that you are able to do things like inferring the embedding width, or and that sort of stuff. So that there's questions about whether we want to do it that way, or whether it's maybe this is unusual for the way the PyTorch models are done, and it'll be simpler for people if we don't get in the way so much, and if we don't introduce our own conventions as much. So let's see how it goes not doing it the spaCy way, and just creating the objects in it like this. Okay. All right. So we're doing it like this. Then so that's what we're doing here. We're creating except so it's all right. We've got an encoder. That's what we're calling this. So that's the same as parent. But let's and so for linear. Right. So then this bit we call this transformer. So I wonder why this actually isn't coming up as a type error, because you don't have a transformer object, right? I wonder whether I need to do something to tell Python that the class is sort of final. And usually you don't. So anyway, okay. So I never understand why it can't make this type inference. Really should narrow the type across that conditional, but it doesn't. Maybe. Okay, so okay. So wait, we don't actually have a hidden width here. It's the linear layer goes directly from the encoder into the image. So, sort of point of detail about this. This was a quick and dirty thing that I actually got Claude to generate. This model is actually really bad. So what this would do is it takes the the embeddings from the transformer, and then it applies a single linear layer, and the outputs are going to be the tag logits. So for every dimension there, you're going to softmax that and read that as the probability of it being a particular tag. Now, if you have an output layer like this, you really shouldn't apply dropout over it, because if you have a sample where you've dropped the correct class, there's nothing that the model can really do with this sample. Like it's the feature of hey, the logit that was applied to this class or that class, that's something that you don't want to drop. So you only want to apply dropout in hidden layers. As a point of fact, usually you actually would want to have a hidden layer in a tag like this. It's not going to, it's not a expensive operation. It's it tends to to be helpful. So we want some sort of non-linear layer. Here we do want a hidden layer. We may as well call it, use a ReLU layer or something like this. In spaCy, actually, we tend to use max-out layers for these things, and I've found good performance from that. But for simplicity here, I'll just use a linear layer. So this is a good opportunity to look at how the general PyTorch functionality for just sort of composing things into a chain. So yeah, it ends .sequential. Okay, cool. Yeah. All right. And then yeah, this takes them as a spread args. Okay, cool. So we go. Yeah. So we don't put the encoder first because we might be taking the embeddings as an argument. So we just want this as the in-between layers. So let's see, we've got our first one here. Then we've got and then dot f dot ReLU. Everybody capitalizes this a bit differently. So yeah, ReLU. Wait. NM not ReLU. Okay. And here we go. Linear, and this is going to be yeah, and then softmax. so we don't do that. Okay, so yeah. All right. We probably actually want to have some, for the actual tagger models and stuff, we end up wanting to initialize these in particular ways. So you usually would end up with some sort of, wanting to refer to these layers by themselves. But anyway, okay, so yeah. Softmax, and go like this. Okay. So yeah, that all makes sense. So now, what would this look like when we're actually serializing? So again, we're going to define this here. We've got like our config there, and then we've got our layers here. So assuming that we don't actually need the, so this raises questions around, if we're deserializing, what if we, find a different config from what we created the model with? If we just try to load in the data, then it's going to be a different shape, and that's presumably an error. So I think it's kind to save. What sucks is if it is an error and you don't save the config with it, then when you're deserializing, you just hit the error, and we've found that unpleasant with Think in the past. It's definitely something which we'd want to avoid. So here we would want to save out the config. So let's go and do that as a basic convention. So we'll go. So let's say that all models have configs. Config bit, and we'll have our encoder, and then layers is or push dot and then dot actually, do we need to save out the layers like that? I think we can rely on this the torch state dict there. We'll end up duplicating functionality for that. So, and then we've also got this free parameter hanging off of use shared embeddings, which is separate from the config, which feels weird. So let's say we do it like this. So we take the config, so all these, no. Yeah. Okay. All right. So we go to save out our dict. We're going to go config. Keep that as something that we do on the unit. And then we'll have our state dict state data. We go and then we go state bytes. Okay, so that's the general thing that we do when we're saving things to a dictionary. We save the config and the state dict data, and then when we're going from dict, we're going to go okay. Alright, so then we go through the name. Actually no. Now we've just got to load the state dict back. So let's see, where did we, what were we doing here when we load back? Okay, so we've got, so first we deserialize the state dict and then we load it back in. So state dict from bytes, yeah, we go byte starter, and then we go torch.load, bytes buffer, bytes only equals true, and then what's this last one? Pickle module equals none. So now we go equals state from bytes, data, state bytes. Okay, and then we go self.load state dict. Okay. All right. And then the rest of this is, pretty simple. We're just delegating, from how we were. So we're going dict data. Here's the message patterns. Then function file. Tiny, like, decisions and stuff here. I always try to make the scope of these of things like file blocks and stuff as minimal as possible. So we want to create the bytes before we open the file, and this way we don't end up with a this empty file if we have an error during serialization. Okay. Similarly, we want to exit the scope and close the file as soon as possible. So we load in the bytes data. Obviously, if you have some streaming operation, then it's different. But if we're going to work on the whole contents, then we load it in like this, rather than keeping the file open within the context manager while we're doing stuff. And then we go returns. Cool. All right. So there's still plenty of questions associated with this stuff. I'm still quite unsure of how we'll actually want this to work in practice, because it, as you start to use these things more, things like passing these configs and passing the initialization and stuff, these are things where it's like, okay, we'll keep it simple and direct and stuff, but it ends up being quite inconsistent and easy and error prone. So for example here, when you're initializing this stuff, let's say like at the beginning of training, the model wants to specify how the things are randomized, because that's actually, it does matter, and the decision there depends on what you're doing, what the context of the model is. So for instance, a hidden layer like this, that's making this sort of transform, usually you want to initialize this with some random initialization, centered around 0. And the details of that were some of the early things which were making a difference in whether people would were training models successfully or not. On the other hand, output layers like this, you often want to initialize to 0, because that way, if you have some class that you've never seen, even from the beginning, the model isn't assigning it probabilities. Whereas if you randomly initialize, when unseen classes can still receive predictions, which feels weird in some contexts. So it's it's conventional to often initialize output layers to 0. And also when you're using the softmax activation, there's no need to have a random initialization. It's not a hidden layer, it's getting gradients directly. So these sorts of decisions, you don't want to have this specified elsewhere. You want it to be part of the specification when you're doing the model, because you're making these decisions around how things are structured and stuff. So you end up with these initialize methods, and the question is when that should be called and how it should be specified. And when you're doing the initialize method, you end up wanting to unpack these layers, and it gets messy if they're not kind of named and they're just kind of part of the sequence, because then you might subclass this or something and you change one thing, but then the initialization is invalid, or this sort of stuff. So so yeah, it's the things potentially need more complexity, and I'm not sure how this is normally handled in PyTorch. Maybe it is just up to every code base to do things their own way with this stuff. So let's see if Claude has any wisdom about handling initialization or parameter initialization in PyTorch. So see, this is interesting details like this. These defaults matter, and yeah, we want to know how things are being done, and if that's always been the default, then that's fine. But there are these decisions to be made. So for instance, it matters as well because we'll want to have some sort of ability to define the models the same way as we had them before for comparison. It'll be quite annoying if we have to define the models in some slightly different way and then the performance is slightly different and we don't know what's going on, because it's easy to make mistakes. So we'll want, at least for something like Tagger, to have the same model architecture that we had before, including the same initialization and stuff. This is fine for now, but things like this rel layer will do it the same way that we were doing it in spaCy, and have maxit layer, etc., and try to get them performing the same. So going through details like what are the defaults of the initialization and stuff is going to be, there'll be a lot of detail in this stuff. All right. So yeah, so people are doing this as part of just the creation of the layer. Okay, so let's say we're just doing this in the constructor like they suggests, bias. It's funny that this is default initialization. I wonder whether this is actually correct. Whether this is true that the default initialization is the timing/the initialization. So Right. So yeah, that is indeed how it's done. Okay. All right. So. So init uniform and just init zeros. That's fine. Okay. Init zeros, and the underscore here means in place. So we'll go set layers -1. Okay. That's whack. Like, how come? Oh, yeah. So that's linear. We want the parameter weights. I think that's what it is. Yeah. Okay. All right. Good. Yeah. Okay. That seems right. Okay. So yeah, except this is wrong. I suppose I can't help myself but do this. Yeah. So I think this is it's a little bit tidier to do it like this and have some properties for these things, because then if we're referring to it within the class, it's fine, and we only have to change it in one place. Like, let's say, we had a dropout layer here, then we just have to adjust the indices in one place. Whereas if you're making reference to them in all sorts of places, especially in code that's using this, then yeah, it ends up unideal. So I would even probably mark this as private, I would say. So Cool. Cool. All right. So let's look back at our notes. All right, we've stubbed out the pipeline. We have a master model, etc. So serialization and deserialization. Let's say that's ticked off. We've got like a basic sketch of this. Oh, actually, wait. We've only got this at the model level. We need to go up and look at this at the component level, but that's going to be the same. You know, as it is in spaCy. So this will be, you know, we're going to return a dict out of our stuff, and we're going to save, you know, the model as part of that. So I guess one question is a sort of duplication. So when we have the components, we don't want to save out the model of those things, do we? Because we've already got it here. So that's a big question. We've got because what we have in yeah. So this makes sense. So if you're just loading back one component, then you would load back the model with it. But if we're serializing the whole pipeline, then we want to load that back as, you know, one model. And when we created these things, we rely on object identity between the, you know, the component models and these subparts of the pipeline model to avoid, you know, essentially having duplicate models in memory, which is something that we wouldn't want. You know, when we go and add a pipe, we're going so do we do the add at the moment? Let me just see where this is. Yeah, so this actually isn't done right now. So we've got our components there, but when we look at the actual pipeline model, it expects to receive this. So we go add model. So yeah, if component then we go no dots. So yeah, when we're adding, we're not duplicating the data, we're just passing a reference into our pipeline model here. Now when we deserialize, it's not going to look like that. We're going to deserialize the component, and you know, we can tell the component not to serialize its model, but the component itself doesn't know whether it's part of a pipeline or which pipelines it's part of or whatever. And so it's natural when you're serializing that object to want to reflect its state. And so the natural thing to do would be to, you know, serialize its model. But this would mean that we would have all of that data in twice, and there would be sort of no record of the fact that these models that belong to components are all things that belong to the pipeline. So I guess what makes sense to do is when we actually add the pipe, that we're going to, I don't know, zero out the model or tell the component that it doesn't own that anymore. I'm not sure what we want to do. So I guess one question, do we want to allow components, a single component to be part of multiple pipelines? Maybe that's not good. Another way to do this is to hold weak refs up to the pipelines that a component belongs to. All right. I'm going to take a break for lunch and come back and keep working on this. So I don't quite know what the stream convention is for this. I guess I can leave it at some sort of window like this and just say and then. Okay. Okay, let's pick back up. Let's see. Right. Okay. So we're dealing with the serialization and deserialization problem, or at least, this question of how we want this to work with the component models. So I think I was thinking about this as I was walking and stuff. Basically, the things that we want to, it's like, what sort of properties do we want of the solution? So, so okay, so these are two desiderata, I think, of what we want of a solution. So we want the component to be able to work independently. I think that that's very reasonable. It's kind of whack if you either create this thing in a non-functional state by itself and it only functions as part of the pipeline, or you create it in a functional state by itself and then you add it to a pipeline and its state somehow changes and now it's non-functional. I don't find either of those situations like very desirable. So but also, if we're running the model for the components as part of a larger, as part of a single model, when we're actually applying the pipeline, we don't want those models to be duplicated in memory. So when we're creating the model, we're doing this with object identity, and the question is, can we get the same sort of thing with serialization? And I think we can, and what we end up with is actually something that looks kind of similar to the way it's done in spaCy. So okay, so So what we're going to do is we're going to deserialize from the pipeline and make sure that it creates the tree of objects in the way that it wants. So let's see, how's this going to work in detail? So we've got our components. So this approach, I think, is not going to work, where we ask each component independently to serialize, and then the package is only the combination of those serialized components. We need to serialize the model as we hold it by itself, and then then for the components, we need to serialize them in a way that we tell them not to serialize their model. So in spaCy, we have support for something like this. We have the ability to say pipeline and let's tagger. Okay. Tagger doesn't have it. Tagger uses the generic serialization. So train the pipe, it's parent class. Alright. So yeah, we've got these exclude arguments. This means that when we deserialize, we tell it what to exclude, because we're going to provide that. And actually, come to think of it, this is exactly the same situation as we have with the vocab in spaCy at the moment. So when you're deserializing, you need, well, actually, it is a little bit different, because you pass the vocab in on instantiation, whereas we're instantiating the components independently in this assumption, and then sort of merging up their models afterwards. Okay, so first of all, I think that we might have done something a little bit wrong in the way that we're doing this model addition. So the way that we've done it, PyTorch doesn't know that these are sort of components. So I think this is wrong. We don't want a dictionary here. There's a special container for this. So let's see. Okay, and then module root. Okay, cool. Alright, so yeah. Cool. Alright, so now what we're going to do is we'll say model bytes equals yeah, okay. So the pipeline. We wanted the util. Okay. Utils. Cool. Alright, yeah, torch state device. And then okay. to say stated equals torch frontends. Components. Then we're going to go self.load state stated and set the disabled. So alright, so now we've set the we've set this from this. Yeah, blah blah blah. Okay, so now let's look at the how we're going to do this in the component. Alphabet enable add model. Yep. Okay. The answer is yes. Okay, so now we've got to get so go school components. Yep. Alright, cool. Okay, then that's something where we need to add it to the base class. So then, yeah, I've got that. We'll have the tokenizer, preprocessor. So this stuff will be things which we can't really serialize because they're callables. Tokenizer we will. Okay, cool. So. Okay. And then go from it. Okay. Equals state and we'll go with separate dot state and input. Then then we go components. And so here's something that's wrong. We need this needs to be a list. It can't be just because we'll lose the order and deserialize. So components. Yeah, so I'll just go components. go self dot I guess the question is whether we so this is again where the stuff we already have in spaCy is sort of complicated and good, and it's a question of how much I want to do on this sort of sandbox. I guess I should focus on getting things working, and some of these details about how this works or should work will be a bit rough. So stuff like this where this way of deserializing will mean that the components that are serialized have to be the same as, well, you need to set up the pipeline in the same order and in the same way when you deserialize as you did when you created the pipeline, which, it has it's fine. So yeah, we assume that the component is already there when we do this from dict. There's no thing where you're like, okay, you created the pipeline, then added a component, and you've serialized it out. But then when you deserialize, you haven't added that component. Then this will be wrong. We're not going to say, okay, now we'll add that component for you. So this also means that we don't need to do this component sort of thing. So we'll go self dot components, so the name component. Okay, and then we'll say dot okay, so what we want to have happen here is the model instance that we need has to end up as a member of that component. So I guess we can pass it in here. So we go model equals self.model dot so we need to get model. Then let's just call it that for now. And then we're going to deserialize there. So yeah, we go to our component, or replace model and now from, I guess. Okay. Okay. So there's a tagger. Yeah. So we have a tagger component here. No. Okay. So then let's think through how this works with the tagger component. Okay, then we'll have PyTorch equals dips. Okay. And then presumably we've got, say, a config plugin. Let's go. Config equals and let's say we've got the labels, something like this. Okay, so there's a bunch of sort of straightforward filling out that could be done here. Again, I think it's not so productive to get too lost in the weeds of the sandbox here and get everything working prettily. What is important is doing it at least just enough that we get the actual real requirements. So for instance, it would be easy to say, oh, you know, it's just a sandbox, I won't worry about serialization. And then that's a mistake because there's, you know, there's decisions to be made there. And, you know, we need to know about those when we're designing how the components and models, etc., all interact. And the questions that, I can't rely on the questions coming to me, you know, up front. I have to sort of go through the process of filling it out, and then I see, actually there's decisions to be made here. That said, there's a bunch of stuff which I've kind of got penciled in here, which I don't need to be doing. So let's trim that out now. So for instance, this notion of, say, like a preprocessors list and stuff, this was a nice, you know, idea of like if we were doing things again, maybe this is a good thing to do. It's not, it's totally orthogonal to the pipeline as it turns out. So let's, yeah, so we don't do this. Cool. And what else? Yeah, this thing of disabling components. That's something which we, you know, actually, yeah, there are things to be done there, because there's the question of making sure that when we disable a component, we're able to disable its model from running as well, so that we can retain that efficiency. So that is something which, you know, interacts with the stuff that we're doing, and it's worth, you know, it was worth filling that out and seeing how it actually worked with the PyTorch models. Let's see what else here. So, yeah, labels. This is something which, you know, getting the labels of all of the components. I guess actually there might be an interaction with the way that works with some other stuff. So that's we'll keep that around. Error handle, yeah, can use that. Let's remove the idea of excluding things at the pipeline level. Okay. So this is all stuff that this is our pro forma from. So we go. We need the 25 bytes. We've already got that. Okay. 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 So just okay. What's going on here? My indentations work. Yeah. Okay. Alright, cool. Now we need to tokenize the dummy. So how are we not? Okay. So yeah, this is actually wrong. We want self.from. Okay, let's simplify this as well. Yeah, there's some temptation to do it that way. Okay, so yeah, we need to jump here. Okay. Let's make this simple and just say it's a serialized model. Actually, this does raise another idea, another way that we could have done this. So what we could have done is serialize all of the component models separately and rebuild it the same way that we rebuild it when we construct it, and maybe that might be better. So yeah, this would mean, actually, yeah, that does seem better. So what we would do in the main model is just not save out its state dict, and its state has to come from the child models. So yeah, all of this, the state dict there, that's all coming from these, yeah. Huh. Yeah, and this prevents us from having the models loaded twice when we do a replacement. So this is definitely better. We should do it. I'll change to do it this way. Okay, so yeah, this is all the same. Okay, so we're not doing that there. And then we go to our component models, and we no longer have this concept of, okay, yeah, component model. So we've got our models here. Okay, then we're deserializing the pipeline. We go. Okay. So then go. And then we go self.ml dot add model model name component.all. Okay, with that, with this. Okay. This message typing now. Okay, then remove that argument. So we do that. Okay, so I think this is pretty much all of the problems solved. I think this is fairly complete as a design. There may be some things around there is still an issue around the initialization. So the questions around how that should work remain. And this would be stuff which interacts with like the config system and that sort of stuff in spaCy. So I think that'll be the question for the next session. Whether to do the initialization the same sort of way that we do it at the moment with a separate initialize method, or whether to do it separately. Whether to do it all in the constructor. So this is it's basically a question of following the PyTorch convention more closely and being more PyTorchish, or following the way that spaCy does it and potentially disrupting the design in spaCy a bit less. So let's go to our notes and just note this down, and then we'll keep that for the next okay. Alright, so now next All right. Yeah, actually, there's another thing with like, so the dynamic resizing stuff is a, more intricate feature that we support in spaCy, that we, I guess this doesn't interact with like the main design. It comes down to each component. Will do it its own way, or decide not to support it. But for example, you can add a new label to the entity recognizer or add a new tag to the tagger after it's already been trained, and all we do is resize the output array and add a new 0 to it. So I guess there's nothing special to be done here with PyTorch. You either decide you can do that with the model that you've implemented, or you decide that you can't, and that's fine. So yeah, okay. I'll just take a quick look at the initialization in spaCy. So what sort of stuff do we do in initialize? All right. Yeah, so we use the initialize for stuff like labels in spaCy. So if you want to provide the labels to your tagger, one way to do it is to provide them as actually a data dictionary in the init, but often you want to read them from a file or something. And there's this, like, the detail of the config is that if you have any paths in the config, they refer to your local directory, and so then it won't work when you load the config back elsewhere. I actually think that we should solve that problem directly, and when we package the model when we package the config, we sort of virtualize the paths and save the any data paths within it. We sort of make a directory and put things in it, and then transform the paths on the way back, so that you can just use a file in your config the way that you kind of expect to. Because the way that it works at the moment, even the spaCy team will constantly have problems with this, because it's just the way that it works is kind of whack. And you want to be able to specify a path, yeah, you can't. So if we do that, the question is what's actually left for the initialize? Like, what do we actually end up needing it for? So let's look at the parser, for instance. All right. So yeah, here, this is an example of something which, in theory, you could have as part of the init, as part of the unit there. Okay, so we initialize actions here. Again, imagine if all of the actions were passed into the constructor of the object. So what's going on here? Yeah, so this is stuff like if our pipeline component uses, say, tagger features or something, and it has these as it's annotating components, then we apply them when we're constructing the stock sample, and then we initialize our model. Then, yeah, okay, so what happens when we actually initialize in the spaCy parser model? Parser model. Let's see, parser. Okay. So where's our transition? So, all right. spaCy now transition. To the framework. Yeah, so the initialization different separation it is really a think quirk. And, I sort of stand by the way that we did it, but in think, you don't actually allocate your parameters until until the initialize. And that means that, when you're deserializing, you're not creating two copies of the parameters. So you've got your you kind of deserialize into an empty object, an object that doesn't have parameters already assigned, and then you get the parameters out of the state and you load it back in. And this can actually matter because deserialization can be, it's one of the points where you get this memory spike because you end up with multiple copies of the data. You've got the copy that of the weights that you've kind of initialized, then the copy that you've just deserialized, and then you tend to also have the byte string still in memory that you used to build these things. So this is the sort of place where your container runs out of memory or something like this. But if it's good enough for everybody else, it's good enough for me. So if PyTorch works this way, and who knows, maybe when they deserialize, they do some tricks, whatever. So I think this is something that probably we don't have to worry about, and it means that it's one fewer convention that we have to introduce differently from PyTorch. So the more we can just accommodate PyTorch models the way that they're implemented without introducing these separate life cycles, the better. So let's assume for now that the initialize just happens in the constructor. So let's see, where's our notes? Okay. So I think that'll be good. We can do that next time. Also, probably we'll need to visit Confection. There's some maintenance work to be done on that anyway, to do with Python 3.13 and some other things. So it's a good time to visit it. And then we can look at implementing this feature, which will free up our design here a lot. Okay, and then, that'll really take care of the label story probably. We'll still have, questions about exactly how the scoring should work, because at the moment it could work the same as it does at the moment, but it feels a little unideal, and maybe it's just something we don't have to change at the moment, I don't know. And then, we can look at what the training looks like in practice when we're dealing with the whole model. Okay, all right. So until next time, I might do a stream earlier next week than Thursday, but otherwise I'll aim for Thursday. And I know the times have been a bit variable, but hopefully I'll start to get more consistent with it. So thanks.